We typically look at common fruit as a casual snack, a grab-and-go convenience item without much underlying complexity. But looking past the yellow peel reveals a highly calibrated botanical mechanism. It is a precise biochemical delivery system targeting multiple physiological networks simultaneously. This ledger maps the core footprint, exactly 105 kilocalories. Expanding, we isolate the primary macronutrients, 27 grams of carbohydrates and 3 grams of dietary fiber. A secondary tier quantifies the regulatory micronutrients, 422 milligrams of potassium, flanked by vitamins B6 and C. We are going to move past basic dietary advice today. The objective is to trace exactly how these specific molecular components interact with human organ tissues on a cellular level. We will map their trajectory through 3 distinct physiological networks: metabolic energy regulation, cardiovascular pressure management, and neurological function. Understanding this exact chemical matrix establishes a required foundation for both clinical dietetics and advanced sports medicine. The mechanical breakdown begins the moment the matrix enters the human gastrointestinal tract. The primary payload is the 27 grams of carbohydrates, which decompose into 3 specific trisugars: glucose, fructose, and sucrose. These sugars provide immediate substrates for adenosine triphosphate, or ATP, synthesis. They rapidly clear the digestive barrier to aggressively restore depleted cellular energy reserves. In this GI tract schematic, 3 grams of dietary fiber act as a deliberate counterweight to fast-moving sugars. Zooming into the stomach lining, the fiber forms a structural blockade. This initiates delayed gastric emptying, deliberately slowing lateral passage into the duodenum. By adding dense physical bulk to the digestive process, this fiber prevents constipation, ensuring structural gastrointestinal health and steady gut motility. The physical pressure of delayed gastric emptying directly triggers neurological satiety signals. It tells the brain that the stomach is physically full. This prolonged feeling of fullness acts as an active mechanism for weight management, naturally restricting the impulse to consume subsequent calories. You have an immediate energetic spike from the trisugars, operating in strict tandem with the slow-release structural pacing of the fiber. This precise ratio prevents a rapid spike and subsequent drop in blood glucose. The matrix delivers sustained metabolic energy without triggering an immediate hunger rebound. Moving past the intestinal walls, the regulatory micronutrients enter the bloodstream. Here, the strict yield of 422 milligrams of potassium begins its work, initiating a mechanical reaction within the arteries, known as endothelial vasodilation. In this arterial cross-section, watch the physical interaction. As potassium ions bind to the endothelium, the muscular walls of the blood vessels are forced to relax and widen. As the vessel expands, the hydrostatic pressure against the arterial walls physically drops. This process corrects internal fluid dynamics, establishing the strict osmotic balance required to maintain baseline cardiovascular homeostasis. Delivering 422 ml food source. Potassium functions as an active regulator of heart health and blood pressure, maintaining the mineral concentrations required for vascular relaxation. This regulatory capability scales directly into conditions of extreme physical stress. During heavy exertion, post-exercise muscle fibers face severe fluid and electrolyte loss, leaving the internal tissue in a highly erratic state. Muscle contractions rely on precisely timed electrical impulses called action potentials. Post-workout muscle cramps are rarely physical tears. They are the painful result of electrochemical misfirings, action potentials triggering uncontrollably due to electrolyte depletion. This diagram highlights the muscle cell membrane, where potassium intervenes. The sodium-potassium pump actively moves ions across the barrier to restabilize the charge. As potassium normalizes, erratic electrical flashing smooths into a steady rhythmic pulse, restoring the cellular electrochemical gradient. Sports medicine professionals utilize this carbohydrate electrolyte matrix to leverage the simultaneous restoration of glycogen and cellular electrical stability. By repairing the base electrical charge of the cells, the matrix serves as a highly specific prophylactic against acute muscular failure. The final phase of this physiological mapping crosses the blood-brain barrier. The critical, often overlooked element of the matrix is vitamin B6, or pyridoxine. Unlike the carbohydrate profile, vitamin B6 contains zero caloric energy. Instead, it performs coenzyme catalysis. In this synaptic cleft representation, B6 particles act as structural bridges, allowing precursor molecules to transform. B6 is required for amino acid metabolism, synthesizing two distinct neurotransmitters, serotonin and dopamine. The accurate synthesis of serotonin is directly responsible for emotional stability and elevated mood. Simultaneously, the continuous production of dopamine ensures acute cognitive health, drive, and mental focus. Working adjacent to B6 is a supplementary dose of vitamin C, operating as a targeted antioxidant to protect these delicate neural pathways from oxidative stress. A positive mood or sharp focus is not a vague abstract feeling. It is a strict physiological output that depends entirely on the availability of these exact coenzymes. The matrix engineers neurological stability by directly supplying the chemical precursors required by our most critical cognitive factories. Stepping back from the microscopic cellular interactions, we can view the holistic impact on the human body. Returning to the initial nutritional ledger, we trace the simultaneous action of the entire molecular profile we have mapped today. The exact ratio of carbohydrates and fiber actively manages metabolic recovery while naturally regulating digestive weight control. The high potassium yield provides continuous, autonomic regulation over systemic blood pressure and arterial tension, and the pyridoxine catalysis actively fuels the central nervous system, maintaining strict cognitive equilibrium. The clinical utility of this fruit stems from its ability to provide targeted, multi-system biological support delivered in a natural package. The resulting profile supports athletic recovery, long-term weight management, and essential cardiovascular defense. In a single 105-calorie unit, these chemical interactions maintain the metabolic, cardiovascular, and neurological systems of the human organism.